to figure out the molecular weight of an unknown acid. So to get started, guys, we're going to be working with one specific substance, benzoic acid. And this, for all intents and purposes, is our unknown. Here is the drawing of it from an organic point of view. And if you take a look at it, this is the actual compound, C6H5COOH. Now, even though you know it, we're going to actually pretend that we don't know it and see if the molecular weight that we actually get in the lab matches up with what the periodic table tells us. Okay. In order to work with this lab, we're going to be using a number of materials. The first is the Vernier Lab Pro, which will be our computer base. We will measure temperature with a temperature probe, which you can see right here. And the setup is going to be a ring stand with a clamp right here. And this clamp is actually going to be attached to a test tube that is going to contain either the first experiment will actually contain your lauric acid by itself, and the second one will contain a mixture of lauric acid with the benzoic acid. Okay, the way that you'll do this is you'll take a beaker, you'll fill it up with some tap water, and that'll be the basically the controlled temperature of which we will be able to freeze these two solutions. Okay, so these are our test tubes. Again, you'll have two different test tubes, one containing lauric acid that I will actually provide for you, and the second one will be a mixture that you yourself will make up. In terms of data to collect, you're going to be actually working on the second test tube, and here you're going to get benzoic acid, and you're going to get about 1 gram, but you need to record exactly how much you've taken up. So if it's 1.03, 1.02, 0.988, whatever the case may be, record that exactly. The same thing for the lauric acid. So the lauric acid is going to be around 8 grams, but you're going to record that exactly. In terms of solute versus solvent, again, our unknown is the benzoic acid, and that will be what you're trying to find the molecular weight of. Your solvent in this case is lauric acid. Now, interestingly enough about both of these, because of their freezing point / melting point is so low, we're actually going to heat this up to turn it into the liquid phase. From then, we're going to cool it in our setup, which we have again over here, and then we're going to be able to watch it cool down. When we do, the graphical data you get is going to look something like this. So for the first part, the first experiment, the lauric acid by itself, which I'll provide for you, will begin to cool slowly, and you'll see that going down and down until it reaches a point where it starts to plateau. When this is flat like that, that's the point at which the liquid is turning into a solid. That point all along there will be constant, and that represents the freezing point of the pure lauric acid. Once all of it's been converted, it'll then continue to drop until it hits room temperature. The second one, which is the solution that you make up, the 8 grams to 1 gram, will have a very different graph in the sense that as it cools down, it's never going to plateau like this one, but instead it's going to start to change its slope a little bit. And when it changes from being pretty dramatic to a little bit more flat here, but not completely flat, that's the point where this solution actually begins its process excuse me, of actually freezing. And that's the information you're going to get from the data to put into your data table to run all your numbers. So you're going to be looking for that very specific point. And again, this is raw data that you're looking at from students in the past. And you can see it's got some ups and downs a little bit in that, and that's going to happen for you as well. When you're done, you're going to process the data by taking your two temperatures and finding out what their change is. The molality you'll then calculate using colligative properties, figuring out your moles of benzoic acid, again the unknown, and then finally calculating the molecular weight like we've practiced in class. Now this will be your experimental value. You'll then compare it to what you theoretically get from the periodic table, and then finally take the percent error. What I'd like for you guys to do as you're getting ready for this is to write the answers to these review questions down on a sheet of paper or on your lab sheet, which is fine. Identify for me the solute, number 1. Number 2, tell me what the solvent is. Number 3, tell me how you're going to locate the freezing point of the solute on the graph. And then finally, number 4, tell me how you will locate the freezing point of the solution on the graph. See you in class.